Welcome, science educators, to this explainer. Today, we're unpacking a truly transformative framework designed specifically for your classrooms. We're going to look at how to design culturally inclusive lessons that genuinely honor your students' diverse backgrounds. And here's the kicker, doing it without compromising an ounce of scientific rigor.
Because let's be honest, this is the vital question we're all facing today. How do we teach science without erasing culture? Traditional science teaching can, sometimes, unintentionally be culturally exclusionary. When we step into diverse classrooms and push only a single, dominant scientific worldview, it can actually act as a form of epistemological violence toward our students' rich cultural backgrounds. So, how do we teach rigorous science while fully validating local and traditional knowledge? Let's figure it out.
Here is our roadmap for this explainer. First, diversity in science classrooms. Second, the epistemological bridge. Third, the foundations of the bridge. Fourth, epistemological independence. Fifth, epistemological similarity. And finally, the bridge in practice.
Section 1. Diversity in science classrooms, beyond exclusion.
Okay, so science education has historically prioritized a single viewpoint. Sometimes, even well-meaning teachers fall into what we call exclusionary practices. Maybe completely ignoring non-hegemonic cultures, or maybe bringing up traditional knowledge, but really only using it as a cute hook or a stepping stone to teach the real science. But if we want to achieve true educational equity, we've got to shift to fully inclusive practices. This means recognizing diverse epistemologies, different systems of knowledge, as completely independent, valid curriculum content in their own right.
Section 2. The epistemological bridge, a metaphor for inclusion.
Based on the research of Julio Cesar Tovar Galvez, the epistemological bridge framework visually maps out exactly how we can connect distant knowledge systems, think Western chemistry and indigenous traditions, through practical didactic principles. It basically breaks a super complex pedagogical theory into manageable, actionable steps for you, the teacher.
Think of this framework as an actual physical journey for your students. First up, you have the endpoints. These are the distinct, independent epistemologies. So, the domain of science on one side and traditional knowledge on the other. Then you've got the walkway. This represents the commonalities, the shared aims and practices that actually link these distinct cultures together. And finally, the transit. This is the active learning phase where your students safely cross those cultural borders to learn new domains, and they do it without ever having to abandon or lose their own cultural identity.
Section 3. Foundations of the Bridge, Theory to Pedagogy.
So, what's actually holding this bridge up? Well, the endpoints are firmly grounded in epistemological pluralism. This is the fundamental recognition that diverse knowledge systems are intrinsically valid in their own right. They aren't just myths, and they definitely aren't just early, primitive attempts at science. No, they are completely different systems derived from unique ways of viewing the world, and they deserve to be treated as valid, independent curriculum content.
Meanwhile, the walkway of our bridge is built on interculturality. If pluralism establishes that these distinct endpoints exist, interculturality is what allows for a symmetrical, equitable, and totally respectful dialogue between them. It's that ongoing process of mutual learning that takes advantage of shared commonalities, so individuals can confidently cross those cultural borders.
And the actual vehicle your students will use to cross this bridge, that's rooted in robust learning theories. Specifically, this framework utilizes the classic three-step structure by McNeil and Krajcik, making a claim, backing it up with evidence, and providing reasoning. What's really cool here is that students can use this exact same framework to construct logical explanations in absolutely any epistemology. Whether they're explaining a phenomenon using scientific data or explaining it using community history and traditions, the structure holds up.
Section 4. Epistemological independence, honoring the endpoints.
The absolutely crucial point to remember is that diverse epistemologies have their own nature, structure, dynamics, and intrinsic validity. Because they're fundamentally independent, we must never, ever use the rules, methods, or standards of one epistemology, like science, to judge, evaluate, or validate another, like indigenous traditions. They can't be mixed, they shouldn't overlap, and we definitely cannot put them into a hierarchy where one is treated as somehow superior to the other.
Let's look at a real classroom scenario that brilliantly illustrates this difference. Imagine you're teaching about biomolecules. An exclusionary practice would be bringing in traditional Colombian huisca-wrapped corn, but solely using it as a fun prop to talk about carbohydrates in the lab. That reduces a deeply rich tradition to a mere context for science.
And inclusive practice, using epistemological independence, involves teaching the deep spiritual meaning of the wrapped corn right alongside the chemistry of biomolecules. Both are treated as independent, highly valuable subjects to learn.
Section 5. Epistemological similarity. Building the walkway.
Okay, so if these endpoints are completely independent, how on earth do we connect them? Well, to build the walkway of our bridge, you and your students need to actively identify elements that share common aims. Because even if the methods are wildly different, diverse epistemologies often have shared practices, values, or goals when it comes to producing knowledge or goods. Finding these similarities, that's what creates the safe walkway for intercultural border crossing.
Consider this scenario. On one side, we have a chemist determining chemical bonds in a laboratory. On the other side, we have indigenous communities weaving beautiful woolen fabrics. Obviously, the methods are entirely distinct, but notice the shared epistemological aim. Both the scientist and the weaver are producing knowledge, information, or goods through direct, hands-on experience. Pointing out this shared aim builds that crucial common walkway for your students.
Section 6. The Bridge in Practice, Crossing the Borders.
In practice, you're going to guide your students through a really structured transit. First, they learn the specific ideas, practices, and norms of a science, like chemistry. Then, they cross the walkway to learn the distinct ideas and norms of a traditional community, such as the Wayuu or the Muisca. They actively carry out knowledge production for both domains. But remember the golden rule. They must assure epistemological independence at all times. When they're in the chemistry lab, they don't use tradition to read the instruments. And when studying a traditional ritual, they don't use chemistry to judge its validity.
Ultimately, this all builds to the final assessment. The culminating learning output of the epistemological bridge is that the student produces two distinct, equally valid explanations for the exact same phenomenon. Explanation 1 is derived entirely from scientific data and molecular structures. Explanation 2 is derived entirely from community history and local norms. By successfully writing both, the student proves they have successfully navigated the bridge. It's a real game changer.
By fully embracing the epistemological bridge, you don't have to choose between teaching rigorous science and honoring cultural heritage. You can absolutely do both, and it transforms the classroom into a space of true equity. So I'll leave you with this provocative thought as you plan your next curriculum. Which bridge will you build in your next science lesson to empower your students' diverse identities? Thanks for joining me on this explainer, and happy teaching.